The world's leading brands rely on data in the moment more than ever before. Whether they're preventing millions of fraudulent credit card transactions, offering dynamic pricing to hundreds of thousands of riders, or sending title recommendations to millions of viewers. This need for data also brings with it a need for evolution. Single Store enables brands to use their data to power the world, breaking away from legacy architectures to shatter data barriers. The time has come. Welcome to the Data Revolution.
Hello everyone, and thank you for tuning in. I'm Michelle Sargentson, Director of Integrated Marketing at Single Store. We've got a fantastic event planned for you today. Everything from new product features and demos to fireside chats with industry thought leaders. So get ready, because we're kicking things off with our CEO, Raj Verma, to share his take on the database industry and the real-time revolution.
My name is Raj Verma, CEO Single Store, and it's my absolute pleasure to welcome you to Revolution 2022. We are going to actually have a real conversation about real time today. I know there's a lot of noise going around in our market about real time. Every man and his dog has a real time system all of a sudden. So we're going to have, as I said, a real time with Raj this morning and with the rest of my colleagues. I think that should be entertaining, at least we hope it is. We're going to talk about the mission of Single Store, and we're going to briefly touch upon the purpose that we all, me and my colleagues here at Single Store, and share that briefly with you. And we also then have some exciting news to share with you, which we will. So, the real conversation on real time. Now, just imagine a day in your life. Let's imagine a day in my life. I wake up every morning, most mornings, to having these Amazon fresh packets outside my door. I help my wife bring it in as I call the Uber to go to the office. And as I ask Linda, who runs my life here at Single Store, to order me some lunch, which she, again, gets delivered most of the time, and I take a Uber back, and on the Uber back, I'm listening to my favorite songs, which is, again, as a service. That is my real-time world. Now imagine that world where the groceries that we wanted this morning arrived tomorrow. The Uber that I ordered to get to the office by 8:30 in the morning got there by 11:30. The lunch came when it was dinner time. The music did not play. You get the point. The real time has to happen now, not 20 minutes later, not 5 minutes later. It is all about sub-second response times. And that's why we wanted to clear the air here with you so that you can differentiate the real real-time companies from all the companies who can talk the talk but cannot walk the walk. And to go there, let's just talk about what makes a system or gives the system the capability to be real-time. It's not magic. It's actually simple. Real-time needs fast. Fast equals real-time. Now let's think about it. What makes a technology fast, a database fast? It's not query optimization. All right, 5, 7, 10% maybe. It's really the storage architecture. We were built to be real-time. We have a 3-tier storage architecture, memory, disk, and object store, which puts us in a very unique position to provide you millisecond response times, to be able to, at the same point in time, give you the lowest TCO of anyone in our industry. Don't take my word for it. We have a study by an independent third party giga-ohms, and I'll highly encourage you to go take a look at that. The second thing which allows us to deliver real-time to you is what we call unification of two real big aspects. The first is the various data models, JSON, text search, streaming data. Now that allows you to do most of your work on one single platform rather than having these swim lane databases stitched on to your database. And the biggest is the unification of transactions and analytics. Now, this has been in the works for over a decade now, so this was a pretty difficult task. A lot of people often ask me, do you really do that? Well, I'll encourage you to try it and let me know, because we actually really do that. And what that allows you to do, and I'm really excited that later last month or earlier last month, we announced Workspaces, the general availability of Workspaces. That allows you to, on the same screen, be able to take a look at your transactions and on the same workload, do your analytics without having to ETL or copy and paste that workload. When data moves, bad things happen, and it introduces a lot of latency. So we are real-time by design because we are fast owing to our storage architecture and our unified data models and the unification of transactions and analytics. You're going to hear later on in the show today from our head of products, Yatharth Gupta, head of engineering, Shirish Thota, and also our customers and partners about, first, how we build this, and secondly, how our customers use this. We are at a crossroad in business today where the incumbent vendors, right, which have a stranglehold on the data industry, are right now finding themselves coming up short to meet the requirements of the modern day. It is our mission to ensure that we can educate you, our customers, prospects, and developers at large, that at last there is a better way for you to shape the future for your organization by using technologies like Single Store, which are fast, they are real-time, they're unified, and importantly, extremely resilient. We are committed to distributed SQL, which will make us among the most resilient technologies or databases in the world. We are committed to ensuring that we always remain real-time in our analytics. And thirdly, we are absolutely committed to giving you, the developers, one of the best experiences that you can get from a database. It is absolutely a privilege to, in some small way, being able to make this world real-time. I was talking about the ride-sharing company. We help them in a little way. When I bank and I log into my bank account, the fraud detection in that bank account, we enable that. Some of the offers that you get when you demonstrate a certain behavior so that your needs and experiences are enhanced, we do that. We help some of the Fortune 100 companies to close their books and report it as a public company on time. Predictive analytics, which allows cell phone towers to stay online for longer, for devices, large computers and servers and equipment to remain on a higher uptime. That is highly, highly fulfilling. But our mission is to continue to push the envelope on data. And that is something that you would see from us in the times to come. Now, as I've always said, and I'll touch upon it briefly, you need to know in the modern era just having the best technology is not good enough. There is no if, and buts about it. The business of business is for profit. That particular line is no longer applicable in the modern business world. The business of business is to ensure that we can affect the lives of people who come in touch with us. We can improve them, we can better them, we can keep them safer. And I just wanted to briefly touch upon that we are not only committed to delivering the best technology, the best experience in real time, but we are also committed to making the world around us better. What drives us is to ensure that everyone is not only born equal, but is also treated equal. And I do want to touch upon some of the issues that the world is facing today and just put it out there as to what our stance on that is. And I think it's important for you developers to know that this technology is built by people who have a greater purpose than just zeros and ones. We are absolutely committed to our colleagues, to the citizens of Ukraine, in their difficult time, in the various atrocities that they've had to deal with. Our employees are safe, they are looked after, and in turn, doing a great service for their fellow citizens, and I couldn't be more proud of them. We absolutely stood by the Pride Month last month in San Francisco. Actually, I had a lot of fun, and it was just awesome. And lastly, just something which is extremely close to my heart is some of the recent rulings that the Supreme Court had. Deeply upsetting for me as a father of two daughters. I'm privy to some very unsettling conversations on the dinner table. I feel for all the women in the world who are hearing this, watching this, and just women at large. These are frightening and unsettling times for all of you, and our thoughts are with you on this. And I just want all of you to know that we will leave no stone unturned to ensure that each and every woman in the world gets the right to the right health care of their choice. There are just no ifs, and buts about it. Lastly, I want to share some really exciting news with you. We, as you might have read recently, announced our latest round of funding. It is just a further validation of support on our mission and our purpose at SingleStore. We are delighted to work with Goldman Sachs, who are not only a large customer, but also now an investor. They have made us better as a company by using our product, and I know they'll make us better as an investor by partnering with us. So thank you. We also welcome the other new investors. Deep gratitude to our partners and investors, IBM, HPE, and Dell. It means the world to us to have you as our investors and to partner with you. The use of funds are actually going to be very simple, very aligned with our mission and our purpose. We will absolutely be dedicated to providing you the real-time experience, so the analytics will always remain at the cutting edge. We will absolutely double down. We are doubling down on distributed SQL so that you have world-class or best-in-class resiliency and uptime. And lastly, on the developer experience. And from our purpose perspective, which is enhancing the lives of people who touch us, we promise you that we'll do everything that we can to give you an equal opportunity in this world. Thank you for your time today. I hope you enjoy the sessions from our leaders, from our customers, and our partners. Stay well, stay safe. Thank you.
Thank you for that inspiring keynote, Raj. Let's dive right into the latest product features and what's new in SingleStore DB with our SVP of Engineering, Shirish Thoda.
Hello, I'm Shirish Thoda. I'm Senior Vice President of Engineering at SingleStore. I'm excited to be here to talk about what's new in SingleStore DB. I have spent the past 2 decades working on various kinds of databases, and I'm thrilled to be here to help with the vision of building a general-purpose unified database for both speed, scale, reliability without losing performance. Before we get into the details of what's new in SingleStore DB, I want to present a little bit of a context and the history of all the work that has happened here. First, the context. If you look at the modern data stack, it's kind of broken. The complexity of these transformations and the silos lead the customers to build a lot of siloed enterprise architectures. What ends up happening is that the time to insight is much larger. They want to minimize it from the time a transactional piece of data enters the system to when the business wants to gain some insights. That essentially means that you need one engine that can build both the transactional capabilities as well as analytical. And SingleStore has been at the forefront of that, and the fact of the matter is that we're the leaders in this space. HTAP is not necessarily a new concept. It's been there for quite some time. Real-time analytics is the killer application, and that has been made possible for some of the innovations like cloud architectures, evolutions in our query engines, etc. And SingleStore has definitely taken advantage of it. If you look at the history of SingleStore DB, we've started out as an in-memory OLTP database. We wanted to provide a really quick low latency access, and we've succeeded at that. Beyond that, we've added columnar formats on disk, foraying into analytics. We've built an amazing architecture known as universal storage, where we could do both the transactions with our row store skip list indexing in memory and columnar formats on disk. We further forayed into tiering the data into an object storage with bottomless architecture. When we did this, we've taken immense care to make sure that we don't impact the operational latency and yet provide an amazing scan performance. The details of this are presented in many of our research papers, including the recent SIGBOT paper. And now we are here where we're focused on building new capabilities for enterprise scale, real-time analytics, and developer experience. Let's dive in. These are the three pillars that I talked about. Number one, enterprise scale. Number two, developer experience. Number three, real-time analytics. I'm going to touch upon some of the core features here. On enterprise scale, we begin talking about workspaces, which is a core feature which is useful for our customers to build isolated compute workspace environments. These isolated environments can be built on the same database, just attached on demand. This essentially means that one could imagine building applications such as point-in-time sales, segmentation, BA dashboards, all on the same data without having to move the data, without losing any performance, and no additional cost. Along with that, we've introduced an HTTP API to interact with our control plane. Also enhanced our security posture significantly. We've added features such as CMK general availability. We've added things like single sign-on with popular identity providers. We also have now support for JWT token authentication. These all features help our customers to have zero trust policy capabilities in their business. Moving on to the developer experience, we start out talking about the code engine. It's powered by Wasm Webassembly. Webassembly, as we know, is very popular for building highly efficient applications for web. Now, the thing is, Wasm also has amazing characteristics such as portability, safety, and the nature of the code format, which is in binary. It helped it evolve the interfaces to be run on different kinds of runtime environments. We're proud to announce that we are deeply integrating this into the database engine so that programs such as written in languages such as C, C++, Rust that can be compiled into Wasm modules can now be run closer to the engine, closer to the data, without having to move the data back and forth. This essentially means that you don't have to pay for the mid-tier unnecessary movement of data, suffer with the latency, etc. And that's a huge step in the right direction in terms of really building a unified interface for doing local analytics. We're also providing support for HTTP RESTful data APIs. And finally, we are enhancing our built-in vector functions, where you can do some advanced algorithms such as image recognition and such within the database itself. Now to the last pillar, real-time analytics. Here we started talking about flexible parallelism. This is a feature which helps the query to take advantage of the entire hardware, effectively running on all cores, a single query running on all cores, which means that the powerful queries, complex queries, can take advantage of it and be a lot more powerful. What used to happen was that we used to provide one thread per partition earlier. Now we divide the partition into logical subpartitions and assign a thread per logical subpartition. This essentially means that we could now exploit all the cores. We've seen some of our customers take a benefit of almost 4x performance because of this feature. We're also excited to announce that our Power BI connector is now certified by Microsoft, so you don't need any third-party extensions. On the Dbt adapter, this helps our developers to build workflow environments. You could do transformational pipelines on the data natively present in SingleStore, further boosting the CI/CD pipelines. So this is about all the features that we have. A lot of these details are going to be covered in the next deep dive sessions. I encourage you to go watch it. But before we go, I want to point your attention to one last thing. We recently have had the study done by an independent vendor, GigaOM. They were looking at our TPC performance benchmarks as well as our TCO metrics. And the idea here is, what does it take for an equivalent system to build something that SingleStore provides natively, to do both transaction and analytics in one place? The results were stellar. The study finds out that we were 50% cheaper for an equivalent stack of Snowflake and MySQL. We were 60% cheaper compared to a Redshift Postgres. Now, once again, you need more than one solution here because you need to have both transaction and analytics in one place. Versus in SingleStore, you don't need to. And that's one of the reasons why it's much cheaper. On the TPC benchmarks, we were found to be 100% faster compared to a Redshift equivalent. I also want to point out that SingleStore is one of the only databases that can do TPCH DS competitively with the cloud data warehouses, as well as TPCC benchmark in a very reasonable scale. Thank you.
Hi, my name is Carl Sever, and I'm a Senior Director of Engineering on the Launchpad team. One of the best parts of my job is building applications which showcase the unique and interesting capabilities of SingleStore database. So when I was asked to build a demo for the launch event, I was stoked. I think the conversation went something like this. Hey Carl, can you make a demo for the 7.9 launch event? No problem. How does a universe simulation sound? You know, just imagine thousands of solar systems full of millions of spaceships. Okay, I get really excited about universe simulations, but luckily Raj said yes, and we were off to the races. So we had an idea. And as I was saying, the idea of thousands of solar systems and millions of spaceships flying around a virtual universe just sounds really compelling. But could you build it using only a database? Could we use one database to do everything needed to power this entire simulation? Well, you'd need a couple of pretty hard features in such a database. The first one is you'd need to be able to handle transactions and analytics at scale. At the very least, to simulate this universe that I have in mind, we'll require over 1 million transactions per second, or more specifically, 1 million update operations per second. And that's just to move the ships around and let them react to their environment. So transactions are going to be extremely important. But while those transactions are happening, we're going to need to run a lot of analytics to be able to render the game UIs and make them look super cool. And speaking of game UIs, well, I don't want to just power one game client. I want to be able to power thousands of game clients, which means that we need all of those analytics to run with high concurrency. So this is just yet another hard problem to stack on top of an already really hard problem. And finally, we would need to be able to extend the database with custom logic. I want my spaceships to have behavior. I want them to have AI, and I want them to be able to react to their environment in a semi-believable way. And for that, I want to write behavior or an AI for these spaceships in a higher level language so I can leverage open source libraries and just use all the tools that I'm used to as a software engineer. So these are my requirements for building a universe simulation. And before SingleStore 7.9 came out, I didn't have all of these things in one database, but now I do. So I'm introducing the Wasm Space program. Let's go check it out. This is the universe. The universe is full of solar systems. Each of these yellow symbols on your screen is a solar system. Currently, there's about 32,000 solar systems in the simulation. And within all of these solar systems is about 1 million spaceships. So we have a live universe that is running in real time. We can see that the current turn time is about 755 milliseconds. As long as that's less than once per second, we are in real time. Everything is running and able to synchronize across our workspaces without any problem. So what we can do here is we can jump into a solar system to see what is happening inside. I'm going to do that right now. So in a solar system, we have a couple of new symbols. These symbols here, the ones that look like asteroids with little green bits sticking out, they are called energy nodes. You can think of an energy node like a phone charger. Spaceships will show up and essentially try to consume energy nodes. And by doing so, they will charge up. And so spaceships, when they're charging, is really good because spaceships need energy to survive. We can see a spaceship over here running around and trying to consume energy. However, spaceships are interesting because spaceships have behaviors. They aren't just dumb spaceships. They actually look at the universe around them and they decide what to do. And this particular spaceship is trying to get energy nodes that are safe. It's only basically going after energy nodes that are not being actively sort of hunted by other spaceships. And as another spaceship approaches this spaceship, it will likely run away. As you can see, it just happened right there. So we have energy nodes, we have spaceships, and they all are basically living their best lives in this virtual universe. The cool thing about this is that all of these solar systems are being simulated at the same time. So I can go anywhere in this universe and see something interesting happening. For example, there's a battle happening right here. These two ships are actually fighting over an energy node. They both want access to it because of the energy that it represents. And if we look at the battle, we see that I would go ahead and guess that this ship is going to win. But you never know. This is an open spaceship, open universe, and at any point another ship could just show up and disrupt this battle and change the outcome. I love simulations like this because they're full of emergent complexity. I have no way of predicting what is happening in this universe. I can only look and observe and see what these ships are deciding to do. So that's a quick overview of the Wasm Space Program. Let's talk about the architecture next. This is the architecture diagram. I want to draw your eye to 3 different areas of the diagram. On the right side, over here, we have our storage. The middle, we have our compute, and on the left side, we have our client. Let's start with storage. As I said at the beginning, the goal of this demo was to run the entire demo inside of SingleStore. So use SingleStore for as much of the compute and storage as possible. So on the right side, we have a database, which is in the SingleStore cloud, and the database is continuously backed up to object storage. This allows the database to be connected to from multiple workspaces, and all the workspaces can see the exact same data as it changes. In the middle, we have our workspaces. This is the compute of our simulation. Most of the compute happens in the writer workspace. The writer workspace is responsible for running each turn. Each turn is a single store procedure in SingleStore, and the store procedure runs in one massive transaction over 2.5 million update queries. Those update queries are really interesting. In addition to changing the data 2.5 million times a second, we're also running Wasm, basically Rust code compiled to Wasm and added to SingleStore. So I wrote the spaceship AIs in Rust, I compiled it to Wasm, and I added it to SingleStore as a new function type. So those 2.5 million update operations are actually running those functions that I defined as part of that transaction. And that's what makes this entire simulation feel alive. In total, during each turn, we run Wasm functions over 6 million times. That all has to happen consistently. So to make sure that no other workloads can affect the turns running every single second on the dot, we split up the workload between the writer workspace, which is this first one here in the middle, and the reader workspaces, which are the additional workspaces below. These reader workspaces have access to the exact same data as the writer workspace and can see it as soon as the writer workspace changes the data. So as those transactions are running, that data is immediately available. But we are guaranteed that no matter how heavy the read workload is, we can't negatively impact the writer workload. And that's really important when you want something to happen consistently at a certain time scale. So we have our reader workspaces, which is where we run our read workload. And we have our game clients. How do they connect to each other? The game clients use our data API, which uses HTTP to connect directly from the web browser to each of the read workspaces and run queries. The game clients are written in JavaScript and are a relatively lightweight client. They send queries to the server and they get some response, and then they render it in the pretty way that you've been seeing. And that's pretty much it. That's how you build a universe simulation in one database. I've been working at SingleStore for over 9 years. And I've seen a lot of innovative technology at SingleStore over the years, and I love our database. But I gotta say, SingleStore 7.9 feels revolutionary. It's the first time I've been able to extend SingleStore with custom logic written in my favorite languages. And being able to do that and combining that with the power of SingleStore with huge amounts of transactions and analytics, massive concurrency, is just amazing. It changes how I think about building applications. I can honestly say that I've had so much fun working on this demo and building this universe and making it feel alive. I hope you had as much fun as I had building it, watching the demo. And I hope you go and take a look at it. It's available on GitHub. The source code's all there, so you can see how I built it and all of my mistakes, all the things I did wrong, everything I did right. You could sort of follow my story. And you can also run it yourself. So definitely take a look at that. In addition, there will be some follow-up videos that go into detail on the different features that I mentioned. Thank you so much for your time. I hope you enjoyed this. Have a great day.
Hi, my name is Bailey Hayes. I'm a software engineer on the Launchpad team, and today I want to talk about a new feature that we've added, Code Engine, powered by Wasm. WebAssembly, also known as Wasm, started in the web, but it's really a portable compilation target that lets you take languages like C, C++, and Rust, compile to Wasm, and then run in any Wasm-enabled runtime, like in the browser, on servers, and in SingleStore DB. Once you have a Wasm module, you run a single create function statement that lets you load the Wasm module to SingleStore. But even cooler, Wasm modules have their own sandbox so that they create their own instance memories for each query that's run. And this lets us run it in the DBMS process. This gives us great speed and performance. You might be wondering, well, I already have the ability to extend the database with user-defined functions and write my own SQL. Well, a lot of companies and a lot of our users move data out of the database to do things like AI, ML scoring. Perhaps they have existing code and existing business logic that they want to run. And maybe porting to SQL is very complex and difficult, but you already have a high-level language that can compile to Wasm, and now you can push that code into the database. So by pushing in application logic and bringing your existing code to the database, I expect us to be able to see all kinds of new and simplified applications running on SingleStore DB. So let's see this in action. You may have already seen our Wasm space simulation run by Carl. There are a number of ships, and each one of these ships is essentially its own user-defined function, its own strategy. The ships here are all running on the default strategy. There might be a few of them that are on the random strategy, but for the most part, they're green because they're extracting energy. They are prioritizing upgrading some of their systems and moving about the screen. Well, let's spice this up a little and add some new strategies. So right now I'll show the functions that we have. We have the default strategy and the random strategy. Random is really just move about the screen randomly. I have already created a Wasm module, and I've put it in a Google Cloud Storage bucket. And with create function, I create a new strategy called flee. And while we're doing that, I'm going to go ahead and create another strategy for battle. Now, if I list my functions again, we should see both of these new functions, both flee and battle. If you want to see what that code looks like, I wrote a really simple Rust program, and it looks for if there are any enemies nearby, and if there is an enemy nearby and we're running the battle strategy, then it will move towards or chase those other ships. Now that we've created that function, we can use it like any other user-defined function. So in this case, I'm going to insert several battleships into our solar system, and then I'm going to add several more fleeing ships that are going to run away from those battleships. And if I look for them, let's search for a fleeing ship. Actually, let's search for a battleship. They're a little bit more fun to watch. And I got the entity ID. Now we're going to warp to it. There we go. And as expected, the battleship is actively engaged in battle. So what this showed is that I was able to modify our simulation in real time without breaking it, without pausing anything, and run at incredible speed and implement new complex strategies. So it's pretty easy to imagine other different types of simulations that we could be running. This could be a logistics simulator of trucks moving across the highway. Or we could be simulating customers moving about in a store and trying to prioritize aisles, like maybe some of our energy nodes, and have a custom model per customer. This is very, very powerful. I can't wait to see what our users create. Thank you.
Hi, I'm Micah Bhakti. I'm the Director of Product behind the Single Store DB Cloud. And today I wanted to share with you a little bit more of a deep dive on our newest feature, Workspaces. So you saw Carl's demo of the spaceships and energy nodes and this massive kind of multi-tenant machine learning application built on top of Single Store DB. I want to show you how we used Workspaces in order to build that demo and how customers can use Workspaces to build their own data applications. So what is Workspaces? Workspaces allows customers to run multiple workloads across shared data. And the challenge that customers had before we introduced Workspaces is that data was locked within the confines of a cluster. So if customers wanted to run multiple applications on shared data, they had to make a choice. Either they could deploy multiple applications in a single cluster, where they had to find ways to manage performance impacts and make sure that analytic queries didn't impact customer-facing workloads. Or the second option was that they could deploy applications in completely separate clusters, but then they had to manage complex and expensive data movement between systems. Now that we have Workspaces, customers can launch independent compute workspaces for each workload, and then they can attach and detach databases as needed. This is super powerful. So let's take a look at how Workspaces work. Workspaces provide an isolated compute instance. And that compute instance can be scaled up or scaled down on demand. Users can attach and detach databases as needed, and each database can have one read-write and multiple read-only attachments. So this enables a bunch of customer scenarios. For instance, if a customer wants to run a customer-facing SaaS application, they can deploy that on a workspace. They can deploy a second workspace for internal telemetry. Maybe that's an application showing them performance of the application for their customers. And they can also operationalize machine learning models on that customer application data. Maybe they want to do targeted advertisement, or they want to do sentiment analysis on their user data. So that's kind of how customers would use Workspaces. Let's take a look and see what Workspaces look like directly in the product. I've logged into the customer portal on singlestore.com, and here I'm in an organization that we've set up for the demo. And you can see I've got two workspaces deployed here. I've got an S32 size workspace that's powering the game engine, and I have a reader that's size S4. And you can see these are both connected to one database. This is the game database. And if I click on the database, you can see that I've got a read-write attachment to the game engine, and I've got a read-only attachment to the reader. So this is a super easy implementation of Workspaces, two workspaces, one database being shared between them. And it's really easy to create new workspaces. I can click on Create Workspace, I can do a new test workspace. I can select the size for that workspace, and this will determine how many vCPUs and how much memory is available for that workspace. And I can click Launch, and that'll go ahead and create a brand new workspace and start spinning that up so that it's available to connect to the databases that are available. Let's take a look at a slightly more complex deployment in another organization that I have. So in this organization, I've got a customer-facing application, I've got an internal app for telemetry for my employees, and I've got a machine learning model that I want to operationalize on top of that customer data. And currently, you can see each of these three workspaces is attached to a database. So this is similar to how you would deploy this in the old model, where each workspace can have an individual database. You can see here, this is the database for application production. I've got an analytics results database, and I've got a model scoring results database. The challenge I have is this customer application. You know, it's got all my data from my usage of end customers connecting to my web portal, my SaaS application. But my telemetry needs to run using this application prod data and then store those results into these analytics results database. So what I want to do is I want to attach this application prod database to this app telemetry workspace. So I'll attach, detach. I'm going to select the application prod database. I'm going to save that attachment. And what will happen is that database will be automatically connected to my app telemetry workspace. You can see now that the app telemetry workspace has a read-only attachment to this prod database and a read-write to the analytics results. So I can query this application prod data in real time, operate on that fresh data, and store the results into this analytics results database. And the workload that's running against this app telemetry workspace will have no impact on the customer-facing application that's running on this other workspace. So let's say I want to run this machine learning model on this same application prod data. I can do the same thing. I can attach that database. I want to use application prod. I'll save that attachment. It'll attach that database to the workspace. And now what I can do is I can take this app telemetry data. I can store it to the prod database. I can read that with my machine learning workspace, and then I can save the results out to this model scoring results database. But let's say I want to take this one step further. Maybe my customer application, I want to actually use the model scoring results to change the application experience. So I'll go ahead and attach that database, the model scoring results as read-only. I'll save that attachment. And now my application will have read-only access to these model scoring results. So I can actually use this in my application in order to deliver maybe targeted advertisements, or maybe I want to customize customer experience based on the types of behavior that they have. So this is kind of a basic example of how customers can run multiple applications on isolated compute workspaces. They can share databases between those workspaces, and they can use it to leverage data applications across their organization on top of shared data sets in order to maximize the value of that data. If you haven't tried Workspaces yet, I would encourage everybody to go to the cloud portal, sign up for an account, and start playing around with it. Check it out. It's an awesome new feature. Gives our customers a ton of power, and it's great to have hands-on experience with the product. Thanks.
Hey everybody! By now you've spent some time inside the Wasm Space program and learned about the amazing tech that powers it. So now you've seen that the game can support over 1 million ships, each one running its own AI through the code engine powered by Wasm, all of that done on a single store DB instance. You've also seen how with Workspaces you can scale out to limitless reads against the database and against the game data as the game progresses. And what you might not realize is that the entire application is just running within a browser. There is no application server farms, no web servers involved at all. So how is that possible? I'm Julie Price. I'm a senior product manager at SingleStore, and I'd like to introduce you to the SingleStore DB data API that enables this massive game to run within a browser. Well, before we see it at work, let's take a look at what the data API is. It is an HTTP endpoint that enables you to run SQL operations on SingleStore DB, and it returns the results in JSON, which is super common data format, really understood by virtually any client, Very easy to build web-based applications, JavaScript applications that recognize and understand JSON. Now, the Data API, it provides dynamic stateless connections, which means if you are playing or running the Wasm Space program and you're on your mobile device and switching cell towers because you're on the train commuting to work, you're going to have a great experience because each request and response is its own independent stream. Now, this provides the ability also to really easily integrate with things like serverless application tiers, SaaS applications, to build web and mobile applications because you don't have to worry about installing a lot of different libraries. You just write the commands and you're ready to go. Now, it also takes advantage of the common HTTP ecosystem and all of the optimizations, all of the evolution that is brought in by all of the companies that are constantly contributing to the HTTP ecosystem. Now, how is the Data API different than other connection options for single store DB? With TCP/IP connections like the MySQL client or ODBC and JDBC, you get a persistent connection. You don't get that network fault tolerance like I was just talking about with the dynamic stateless connections. Also, when you have your application and database running in different networks, you often have to set up a VPN, you have to set up load balancing, and all of this is very static and stateful. If anything changes about the VPN, about the load balancers, then the application has to change. With the Data API, the image might look very similar, but we are taking advantage of out-of-the-box HTTP capabilities like HTTP proxy and load balancers. And all of this is very, very fault tolerant, it's very dynamic, and it gives us the ability to have those stateless connections. One other thing I want to mention here is the concept of connection pools. When you're opening a lot of connections against the database, it can really slow things down. So the Data API not only manages connection pools for you, but it does it dynamically so that you don't have to worry about startup time or anything like that. And you don't have to worry about the headache of managing those connection pools. Now, one last thing before we see it in action, the life of an HTTP SQL query using the Data API. Your application is just going to send the query request into the HTTP endpoint. The endpoint, the API, is essentially going to send that query over to Single Store. It's going to get the results back, serialize them as JSON, and send them back to the calling application. Each request, each response, its own independent stream. Now let's take a look at it in the Wasm Space program in action. So, in the Wasm Space program, we've got all of these different solar systems. Each solar system has a bunch of ships that are essentially going around, they're battling with each other, they're eating up energy nodes, and we can see lots of activity happening here within the application. Now, what I really want to show you is the power of the Data API. Now, all of the requests and responses back and forth from Single Store DB are happening with the Data API. And just to show you in action, here's a query that's showing us the various different strategies that ships are using for play. So here we can run this query, we can see some are fleeing, actually most ships are fleeing, some are battling, and some are just using the default strategy. And as I run that query, you can see that the values are changing over time. Now, if I just wanted to see the total number of ships in the entire universe, in the entire galaxy, I'll just change that query and go ahead and run it. And we can see we're sending a request back every single time that I click this button. And all of that is happening over the Data API, all through this web browser. So I wanted to thank you for the time that you've spent with me today. It's been really wonderful, and I hope that you'll check out all of the amazing new features that we're launching as part of this summer launch. Thank you.
Thank you, Sharish, Carl, Bailey, Micah, and Julie for a look at the incredible new features in Single Store DB. As you can see, our engineering and product teams are constantly innovating to push the boundaries of what Single Store can accomplish for you and your business. Next up, we have VP of Product Management, Yatharth Gupta, with our product vision and roadmap.
Thank you, Michelle. Wow, those were some amazing demos from our team. I'm looking forward to seeing how our customers use these features that have been launched today. Hi, my name is Yatharth. I'm the head of products here at Single Store, and I wanted to talk to you a little bit about our vision at SingleStore. Since our inception, SingleStore has always been about enabling data apps. Our database is built with this intent in mind. How can our customers build data-intensive apps, real-time apps, intelligent apps, apps that do much more than just writing data? Back in the day, apps used to be about doing order entry, just adding data to the database. Today, apps are very different. Take a look at Uber. You are matching drivers with riders. You're providing real-time dynamic pricing. You're also getting other content, like offers that are tuned based on where you are and where you're going. At SingleStore, it is our belief that a single database, needs to support these intelligent applications. Not a cocktail of databases, not data constantly moving from one system to another, and hence adding more points of failure, but a single database. We have been evolving to lead the market to enable our app developers to be able to do this. We started at SingleStore with an in-memory database, allowing our customers to build apps with the fastest response times. As apps become more intelligent, they not only needed to read and write data at a high speed, they also needed to reason on data. We built, way back before it was popular, a single format that could be used for OLAP and OLTP, allowing customers to read, write, and reason on data. Zero data movement in a single database. We then added tiered storage. Customers were able to get the same speed, but also store data in a nonlinear scale in an affordable manner when data was not being used. As customers' need for security and compliance grew, we continued to be at the leading edge of this. You heard earlier today about Wasm and Workspaces. You can, without moving any data, now build complex reasoning on data using arbitrary code. One small example is running sentiment analysis. Imagine you have petabytes of data in your database. You can now run sentiment analysis right there in database using Wasm. This has been a fun journey for all of us, but we have a lot of work to do. Our ambitions are of tall order, and our vision, build an easy-to-use single database for all your needs. This is what we are looking at over the next 3 years. We want to continue to enhance our distributed SQL. You can come to SingleStore, build geo-distributed intelligent apps that read, write, and reason on data, scale them up and down with your needs, and the data is always durable, highly available across geographies where you're using them from. Developers are our bread and butter, and we want to meet them where they are. We want to make it delightful for them to use our database. We're going to be investing a lot more in common constructs like Mongo, Postgres, or T-SQL APIs, in addition to the MySQL that we already have, allowing them to come easily to SingleStore. We want to deliver a zero-trust database. We are continuously enhancing all of our common controls, and we continue to add compliance and certifications that allow our customers to secure their data with the highest of standards. With petabyte-scale analytics, we will continue to enhance all of our offerings on the analytics side, whether it's JSON analytics, materialized views, to operating over very large sizes of data with the same speed and efficiency that we offer today. These are the 4 cornerstones of our vision, and we plan delivering on this starting today. Today we have Workspaces and Wasm that are launching, and we look forward to delivering on this vision, allowing our customers to build their most data-intensive apps with SingleStore. Thank you.
Revolution is just getting started. From here, we've got 2 breakout tracks for you to choose from. The first is our IT and business leader track with CIO Oliver Schabenberger, focusing on data intensity in action. The track includes customer panels with Siemens and Impact, a partner showcase of the IBM Data Fabric with Chris Sobler, and a fireside chat with John Foley, founder and editor of the Cloud Database Report. The second track is for developers and engineers. Go under the hood with CTO Adam Prout for a guided look at building a database for real-time applications, as well as deeper dives into our new product features, including Workspaces, Code Engine powered by Wasm, and more. Click the Events button now, and we'll see you in the breakouts.
Hi, I'm Adam Prout, CTO and co-founder of SingleStore. And today I want to talk to you about why SingleStore DB is great for real-time applications. This is going to provide some context for some of the later talks we're going to hear today in our developer track about the latest and greatest features in SingleStore. But this talk is more about what SingleStore DB is already very good at today. So to start off, what is a real-time application? This isn't an industry standard term. You're going to hear lots of different terms. I think they all describe a very similar use case, maybe data applications, maybe real-time analytics, maybe analytical applications. They're all going to describe use cases that have analytical query shapes, so not just simple get and sets, and yet they're going to combine those analytical query shapes with operational requirements, so low latency, high concurrency. They want it to stay online at all times. Because the analytical query is kind of feeding up through an application. So you can consider it faster, fresher, more precise analytics. To make this more concrete, here's an example real-time app. Obviously, it's a generalization. Each app might be different, but you often have data streaming into your database, in this case, SingleStore. The data that's streaming in could be from Kafka, as we show here. It could be directly from an app. The data could be IoT event data. It could be telemetry from another application. It could be market feeds from external sources. But the key thing is that the data is being streamed in as it's being generated. It's not being batch loaded. Once the data is in the database, you're going to want to serve low latency analytics from it. The analytics could be feeding in through an application. It could be feeding in through a dashboard, which is customer facing and so has kind of lower latency requirements. It could be for doing interactive analytics, so analytics at kind of human speed. And to make this more concrete, I'm going to talk about a few examples of real-time analytics in SingleStore DB's customer base. And so this use case happens across multiple market segments. IoT is a very popular use case, a market segment for this. So a great example here is telemetry coming off of oil wells, and then doing analytics on that telemetry to detect maintenance issues early with the wells, to do profitability analysis on the wells, should we continue drilling, and day-over-day analysis of how the process is going. Another example is in telemetry coming off of cell phone towers and doing analytics on that data to detect quality of service issues early before customers detect them. Fraud analytics is another place where this happens, where you have a stream of potentially purchase information or other events that is going on in a customer account, and you want to detect if there's fraud, if there's something unusual happening on this account. You can see all these use cases kind of involve the streaming of data, and then you want to do these low latency analytical queries on that data. So now, why SingleStore DB for real-time apps? Well, this is a use case we've been doing for a long time. So some of the earliest customers of SingleStore DB were using us for real-time analytics, and they kind of pushed us in this direction of building a more general purpose database. Because remember, real-time apps have some of these qualities of analytics. They want to run analytical queries, and they have qualities of an operational system that wants to be lower latency and stay online. And you can see some of the media companies up here, Comcast, Hulu, Disney. They want to do personalization over the kind of live stream of data, what you're watching, what you have watched, what you've seen, which other things you've maybe watched quickly and didn't continue. And they want to pop up recommendations to you. And Uber is very similar. It's also popping up recommendations based on geospatial data of where you've been in the past and where you're going today. So these early customers really pushed us in this direction. And over the last 10 years, we've built lots of capabilities into the product to satisfy these customers. And to make this more concrete, I think there's 5 key areas of the product that we've built things that are great for real-time apps. Today, I'm only going to talk about one of them, and that's kind of universal storage or flexible indexing. There's a blog post that's kind of linked at the bottom there that'll go into detail on all of these areas, but today we're going to focus just on flexible indexing. So what does that look like? Well, or why is that important for real-time apps? Well, as we said earlier, we want to drive down the latency of our queries. And there's not a lot of magic to that when it comes to a database. That means your database needs to query less data to answer the query. It can't scan lots of rows to answer a query. And so how that works in SingleStore is we have a storage design that has the fast scan performance of a column store. So that's what's going to be in your classic data warehouse, your Redshift, your BigQuery. And on top of that gives you the point read and write performance of a row store. This is like your Postgres, your MySQL. And what this ends up looking like is on the right of the slide there. It's called a log structured merge tree. And I'm not going to describe it in too much detail. It's a layered data structure. The top layer is in memory, and the bottom layer is kind of immutable ordered files. There's a link at the bottom to a paper. It's a very recent paper from a few weeks ago even, and that was released and published in SIGMOD, which is kind of the premier database conference for database practitioners and researchers, that describes really how this works. But today, I'm just going to show some of the capabilities and show what it can do as opposed to describe kind of the exact layout of the bytes on the files. So the first thing it can do is give you the premier scan performance of a column store. So in this kind of simple example, we have a trades table with 57 billion rows in it, and we want to find the top 10 most traded stocks. And we can do that, and you can see on the right there, in 5 milliseconds. And if you kind of extrapolate that out, that's equivalent to scanning 1.3 trillion rows a second. So this is very fast scan performance of a data warehouse, of a column store. The blog post that's linked at the bottom goes into a lot more details about how this works, if you're interested. But this is just kind of a proof point that, hey, the analytical capabilities of SingleStore are best in class. On top of this, let's say we wanted to find the top 10 most traded stocks for a single customer, that we add that customer ID filter. In SingleStore, we can put an index on that customer ID column, and we can speed this query up by 10x with that index. Now, on your data warehouse, on your Redshift, on your BigQuery, you don't have indexes. You don't have this capability. You don't really have the option of driving down your latency. Of course, your operational system, your Postgres, has indexes, but they don't have that fast scan performance we just showed on the previous slide. So this is kind of you can see how the data layout is more flexible in SingleStore, so you can kind of to get both of these capabilities, the low latency reads and your fast scans. Now, on top of this, we also have unique keys on top of the column store. And what this lets you do is insert rows, and if you hit a duplicate key error, there's that on duplicate key update clause there, and that lets you update the row. It's kind of upsert, and if you're familiar with MySQL terminology. And this is very, very rare for a column store. Almost always, if you're inserting into a column store and you want to deduplicate, you have to use another system, another database to deduplicate and then batch load. But this primary key support lets you just stream directly into SingleStore. And if there's a duplicate, you can deal with it as you're inserting. And again, there's a blog post linked at the bottom there that goes into a lot of detail about universal storage. But as kind of a proof point, since there isn't an industry standard benchmark for real-time applications, we wanted to kind of prove that prove to folks that we can do what we say. We ran 2 industry standard benchmarks, so TPC-H and TPC-C. Now, H is an analytics benchmark, so it's 1 terabyte of data, and it's complex query shapes. And so you can see that orange-yellow bar for SingleStore DB. We compared against 3 other systems, 2 cloud data warehouses and an operational database. And you can see the yellow bar for the cloud data warehouses. It's the same as SingleStore DB. We can match kind of the premier cloud data warehouses on this difficult analytics benchmark. You can see the operational database did very poorly on this. And so when I say operational database, I mean like a Postgres, MySQL, SQL Server, something isn't designed for analytics. And it didn't fail to run the benchmark. It just ran it very slowly. We gave up after 24 hours. This particular operational database doesn't have a column store. It's not designed for analytics, so it couldn't do it very well. Now, if you look at the blue bar, that's TPC-C. And so that's an operational benchmark. So that's a much smaller data set, maybe 50 gigs of data, lots of point read and write queries, very high throughput. Now, the cloud database on the far right did very well with this workload. It was designed for this workload. SingleStore DB also did well on this workload. The cloud data warehouses in the middle, you see they have 0 because they just do not have the features to run this workload. They can't run it. Their workload requires primary keys. It requires strong transactions. It requires point updates and deletes, which some column stores don't support. Others support them very poorly. So this is kind of a proof point that SingleStore DB can run mixed workloads. It can run transactions. It can run analytics. And that's kind of a requirement for real-time apps that want to combine these analytical queries with kind of lower latency kind of inserts and also lower latency kind of query performance. So hopefully that provides some context on why SingleStore DB is great for real-time apps. some of the features we have, and pointed to many blog posts with more details that folks can follow up with offline. Next up, we've got Director of Product Management, Eric, with 10 new toys for developers in the Summer 2022 Tool Truck. Eric, take it away.
Hello, I'm here to tell you about 10 new toys for developers in Single Store DB. And I'm Eric Hansen. I'm Director of Product Management here at Single Store. And let's talk about some new stuff. I'd like to say that the Summer 2022 Tool Truck is here. And I used to work in a gas station pumping gas in the state of Oregon, where they still pump the gas for you a long time ago. And I worked with two mechanics that were so excited when the Snap-on tool truck arrived that they literally ran down to the truck and you could see the bottoms of their feet, and they almost always bought a new tool whenever the truck came. So I know that you're excited as developers when you get your hands on new exciting tools in your data platform to use. And so that's what I'm going to tell you about today, some new tools that you can use in exciting ways to build applications. So there's a bunch of exciting new features. I'm not going to talk about them all right here, but this is the list of features I'm going to talk about. Some big ones include things like Workspaces and Code Engine powered by Wasm for extensibility with new user-defined functions written in any language you want. And there's a bunch of other new cool features, and we'll get to them one by one. First, Workspaces. So the idea behind Workspaces is that a workspace is like a cluster. It's a set of hardware that you can attach databases into. You can have more than one workspace attached to the database at the same time. One of them can be read-write and the others can be read-only. And this allows elastic scalability, allows you to separate OLTP from analytics. You're always going to have fast commits. You can update on the read-write workspace really quickly. You can save money because you don't have to over provision. You can spin up a read-only workspace when you need it to handle a burst. So we think people are going to love this, so give it a try. Next, Code Engine powered by Wasm allows you to extend Single Store with functions implemented in languages like C, C++, and Rust, and they run in the database and you can call them from SQL. So your Wasm module runs in a sandbox in the database, and it allows you to call that code from SQL, which can allow you to do amazing things like you can take libraries of existing code or code from your app and create user-defined functions for that and call it from SQL. On the left, there's an example of Levenstein distance as a UDF implemented in Rust. And you can call that from SQL and find like partial matches of license plates, something really practical and there are lots of examples like this for fuzzy matching or partial matching and many more. Next, flexible parallelism. So what is it? In the old days, we had one thread per partition for parallel query processing. Now you can have n threads per partition with flexible parallelism. So you can use all the cores in your system to speed up one query. You can run individual queries faster. The subpartitions are created when the database is created. And this enables elastic scaling, so it fits together with Workspaces pretty nicely. Next, automatic MA failover. This has limited availability by invitation only right now. We'll GA it later this year. The basic idea is that if an MA fails, we detect it automatically. We can elect a new one based on a quorum of voting members, failover to have the MA be one of the other aggregators that was a voting member. This requires premium edition. You need to be running on our cloud. The benefits of this are high availability for DDL, ref table updates, and leaf failovers. And now we can tolerate loss of an MA server or an entire availability zone on our cloud platform. There's no human intervention required. This is fully automatic, and this gives you better overall high availability. Next, computed column matching is a really fun and exciting new feature for developers because people may want to have an expression that's used frequently in a query and would like to be able to speed up computation of that expression and also build indexes on that expression. So for example, You might have a JSON column. You might want to pull a property out of that JSON object and promote it to another computed column. And then you might want to create an index on it even. So now you can do that with computed column matching. Select for update on column store is a new feature that used to only work on row store. Basically, it allows you to do serializable isolation, which is useful for certain OLTP transactions, by holding locks on specific records until you commit a transaction. So it's good for certain, for example, financial transactions where you absolutely want to make sure that you have serializable isolation. So in the example on the right, you can select a row for update, and that's locked until you commit. So then you can calculate some new value, update it, and then commit, and then the lock is released. And so now you can process OLTP applications on data much bigger than will fit in RAM, because you don't have to use row store for this anymore. You can use column store. Also, we now support set. Set used to be a no-op. Set is for session variables, @ variables. This, funny enough, has worked for many years as a no-op, just so we didn't have incompatibility with some MySQL apps that use the set statement. We didn't want those apps to crash, but they actually weren't behaving as expected because set was a no-op. You could use select into in order to accomplish the same thing, but that was a little less convenient than just using set. So now the set statement works as expected, and I guarantee that many of you will be using this because it's just convenient, and lots of other database products support it. So now we do too. Also, we have new vector functions available, like vector sort, vector element sum, and several others. These complement our existing vector functions, things like dot product, that are used for AI matching. And the benefits are that these new functions are really fast. They enable vector apps in general, and an example is one of our customers wants to use it for a value at risk calculation in the financial industry. They used to have to extract the data into the app tier to do this, and now they're going to be able to do much more of it in the database. It'll be more convenient and faster for them. And value at risk calculation is to help calculate overall portfolio risk to make sure that, like, banks or trading companies are not overweighted in any one sector or company. That's just one example of many that you can do with these vector functions. We now support a HTTP data API. The basic idea is that you can use HTTP to request results from single store DB, and you get responses back. And it has dynamic connection management. It's super convenient. It supports virtually any kind of client, and it lets you take advantage of this HTTP ecosystem. So for people that are developing mobile and web apps, for example, we think this will be really convenient, more convenient potentially than using other APIs like ODBC, just less code and less connection management. Jwt Authorization is now also available. Basically, JSON web tokens are used to authorize connections to single store DB, and a client can log in, get a JSON web token or JWT, and then for the rest of their session, they can log into single store DB with that token. And so it's a convenient way to handle authorization, and eliminates the use of passwords. So we think this will be very popular. JWTs are very popular for building distributed applications and handling authorization in a convenient way. That's it. Thank you. So try the 10 new toys for developers. We think you're really going to like them. Thank you for listening. Bye-bye.
Thank you, Eric, for that great look at the exciting new features coming to Single Store DB for developers. Let's keep things going with Senior Software Engineer Lewis, who's giving an in-depth look at Workspaces, the brand new elasticity feature in Single Store. Take it away, Lewis.
I'm Luis, and I'm a software engineer based in Lisbon. I've been working at Single Store in the cloud team for almost 3 years now. Today I want to share with you all some more details about this new exciting feature we have just announced, also known as Workspaces. I will start by explaining what Workspaces are, give some more technical details about them, as well as a demo using our REST API to automate different workloads. So last year, we announced full separation of storage and compute. Basically, without that workspaces wouldn't have been possible today. They are really the foundation, the base of everything. Yeah. But before going too deep, let's first do a very quick recap about workspaces. So as we can see in this picture, their main goal is to provide separation of compute and compute, so you can have multiple workloads attached and sharing the same database inside an isolated environment. So each environment is basically a workspace, so you can run a different workload inside each workspace, and they will have some isolation. So let's say that you need more compute resources on the workspace 3 because the workload that you are running there is very heavy. So that's easy to do. You can scale that workspace independently, and that will not affect the other workspaces. That's also true for the opposite thing. So let's say that the workspace 2 doesn't need to be active the whole day. So you are running a workload that only needs to run during some hours during the day. So you can very easily terminate it at night, and then whenever you need it again, like let's say in the morning, you can just recreate it and all the data will be there available. This is very useful because you can save up a lot of money with this. Yeah. At this point, you are probably wondering, so all the workspaces work internally, right? So as I mentioned before, workspaces are only possible due to our separation of storage and compute architecture. In this architecture, we rely on a 3-tier storage model composed of memory, disk, and remote storage such as S3. We try to combine these 3 storage types in a very neat way so we can get the best of all the worlds. So we use memory as a buffer for high throughput in inserts. We use disk for better analytics performance, and we rely on a column store structure underneath, and also remote blob storage, so we can have unlimited storage and ensure that we don't lose any data. So yeah, by looking at this picture, it starts being very clear where this separation between storage and compute happens. So if we would draw a line here, that's where the separation would start. So on the bottom, we would have the databases, the storage, and on the top, we would have the compute. And this compute will be basically cache. So a workspace will be composed by memory and disks. And yeah, these memory and disks are really just cache, as I just said, and this enables us to have faster query processing and ingestion. And also, these workspaces, they don't need to have all the data there. So if you are running a workload that only needs 10% of the data of that database, even if your database is huge, that's fine. The workspace will only need the required data, the portion of data needed to run that query. So yeah, there is also another interesting question that you might be wondering is, how fresh is the data in one workspace? Doesn't relying on remote storage adds a big delay on that? Yeah, it's actually not that long. So because of the way we do separation of storage and compute being so unique, we don't need to wait for an insert to reach the remote storage to mark it as committed and ensure data persistent. We rely on high availability for that. So any new changes, an insert or an update, they will always be transmitted to at least 2 partitions in memory to make sure that we don't lose any data. So yeah, taking that in consideration, we can have replication directly of fresh data between workspace nodes. So this means that the remote storage is very rarely a bottleneck, and also that the replication will be done quite fast. So yeah, if we look inside the workspace, they have a very similar architecture to a normal single store cluster. So they will have their own set of aggregators and leaves. So this means that a workspace is isolated workspaces are isolated between each other, and that you can add more aggregators and leaves to one workspace without affecting the other workspaces because these nodes, they are not shared between each other. So it's time for a demo and see workspaces in action. I will be mainly using our REST API to create workspaces. So first of all, in order to use this API, we need to create a new key. And this key will be an authorization token to access this API. So in order to do that, we can access the portal single store UI. And in this UI, you will have a section to manage and create new keys. In this case, for this demo, I will be using an existing key that I created before. And I already have a bunch of curl commands prepared. So this first command will create a group. And we first need to create a group because we need a wrapper to workspaces and databases. So basically, databases can only move between workspaces that belong to the same group. Let's do it. Okay, so a group was successfully created. So let's now try to create two workspaces. We just need to make sure that they are created inside the right group. So let's point to the right ID. So the first workspace was created. Let's create the workspace 2, demo 2. And yeah, so now we just created two workspaces inside the group. So yeah, if you need to check like all the operations that we support, you can refer to our docs. There is an API reference page, and this page even helps you to generate the curl commands if you just want to play around with the API. And you can just come here and play around here with the parameters, and all the commands will be generated for you. So yeah, let's now take a look at the UI. And yeah, here you already have a dashboard with the resources that we just created. So you can see two workspaces here, demo 1 and demo 2. So we can try and now load some data into one of the workspaces. So let's just use our tutorials for that. And here we can take advantage of some sample data that we have. So let's load some stock trades data. And yeah, let's try to load it to the demo 2 workspace. So let's try it out. Yeah, this usually takes around 20 seconds to finish. But yeah, in the meanwhile, we can create another database, empty one. So yeah, now we have a workspace with the data set the sample one, and the other workspace has an empty database. So we can also now attach this sample dataset to the other workspace. So yeah, now both workspaces have access to this database. So you can run different workloads in them, and they can be sharing and reusing the same data. So let's give it a try. Let's go to the SQL editor and try to run some queries against it. So the tutorial already provides you some useful queries. So let's try this one, that it basically finds the most traded stocks. And now we are running it against the demo 2 workspace. Yeah, we can see that it was quite fast. And now we can try to run that same query in the other workspace. And that workspace will still also have access to that database, and they will all both return the same results. So yeah, that was everything I had to show you today. I really hope you are all as excited as I am about this new feature, because it really makes new use cases that we couldn't do before possible. So that's super cool. And yeah, if you have any questions, just let us know in our forum. You can access it at forum.singlestar.com, or if you want to try Workspaces out, just go to our portal.singlestar.com and create a new account and just play around with them. So cool. So really thanks for your time.
What a great look at the demo of Workspaces. Thank you, Lewis. We've got more great feature deep dives. Let's hand it over to Peter, a senior software engineer from SingleStore's Launchpad team, to talk about Code Engine powered by Wasm, which we believe is the first production integration of Wasm into a SQL relational database. Over to you, Peter.
Hello, my name is Peter Viteri, and I'm a software developer on the Launchpad team here at SingleStore. For the past several months, my team has been adding support for WebAssembly UDFs to our database engine. We've just released our first production version of this feature, and we're excited to share with you how it works. In this talk, I'll walk you through a simple but practical example. We'll discuss certain design considerations, and then explore a possible development workflow. WebAssembly, or Wasm for short, is a compilation target now supported by many programming languages. While traditionally browser-oriented, it is increasingly finding utility on the server side as well. Its design is focused towards security and performance. As well as being language agnostic, these characteristics make it ideal for writing server-side plugins. Indeed, this is what inspired our choice to introduce support for Wasm in our own database. User-defined functions, or UDFs for short, are a common way that databases allow users to add custom logic to their queries. Until now, UDFs have only been possible in single-store DB through our proprietary dialect called MP-SQL. As we'll see, however, Wasm UDFs bring our engine's extensibility to a whole new level. When designing a Wasm UDF for single-store DB, there are some important factors to take into consideration. First, Wasm UDFs in single-store DB can only return a single value, not a table. While we do also have some support for table value functions in our first release, this is still experimental, and we'll remain focused on UDFs for this discussion. Second, Wasm UDFs are passed values directly from the database engine and do not use an iterator abstraction. This means that, for now, a Wasm UDF is only aware of one row at a time, and exactly one output row must be produced for each input row. There is no intrinsic state kept between calls. Third, you'll need to consider your interface types when choosing your programming language. If your Wasm function only passes numeric information, then it may be written in any source language that compiles to Wasm. For more complex types, such as arrays, records, or strings, single-store DB currently only supports Wasm UDFs compiled from Rust, C, or C++. Now let's dig into a practical example. I found this interesting data set on Kaggle.com. It consists of 3 million headlines collected over a couple of weeks from thousands of different news feeds from all over the world. I thought it might be interesting to learn which news sources are the most active for any given language. To do this, we need to have some way to identify the language used in each headline. This information is not provided directly in the dataset, but fortunately, there are some great language detection algorithms out there. Unfortunately, these algorithms are not trivial, and it would take a significant amount of time to write one from scratch in MP-SQL. Now, this is where the power of Wasm really shines. Since we now have the ability to write our UDF logic in Rust, we instantly have the vast catalog of pre-written libraries on crates.io available at our fingertips. This shouldn't take long. After some research, I've settled on a great language detection library written in Rust by Sergey Potapov. It is called WetLang and has a nice clean API that will make it easy for us to wrap it up. Now that we've decided on a library, we need to describe our Wasm functions interface to the database. To do this, we'll make use of an emerging IDL syntax standard called WIT. WIT allows you to define your Wasm functions interface in a language-agnostic way. You can then pass your WIT specification to a binding generator to help you generate a Wasm module capable of handling complex types. Here is our WIT file. It's pretty simple. Now let's look at the implementation. Here we go. Thanks to the power of reusability, this is all of the source code we need to accomplish our goal. And the top part is actually just boilerplate code required by the binding generator. The bottom half contains a definition of a function I've named guessLanguage. This is the function that we will be surfacing to the database through the UDF. It basically just wraps the WetLang API function called detect. Now to compile it. At the very least, we will need the Rust toolchain, WASI libraries, and the tool that generates the WIT bindings. Fortunately, SingleStore has developed and open-sourced a development container with all the dependencies you need. We just need to give it our project directory. So just a minute while I switch desktops to demonstrate. And here we are. Compiling is simple. We just need to make sure we indicate the WASM32 WASI target. And we can now find the resulting Wasm module down in the target directory. Now let's do some unit testing. To help with this, SingleStore has open sourced another useful tool called RIT for WASI Reactor Interface Tester. We can use this tool to easily run a batch of inputs through our function and examine the outputs, or see if it crashes. It is much easier to do this kind of testing before deploying the function to the database whenever possible. I've already taken the liberty of preparing a collection of headlines for testing. Let's see how they fare with our tool. Uh-oh, looks like we found a bug in the code. This message indicates that the error happened on line 8 while trying to unwrap a none value. Also, it appears that an empty string is being passed in. Let's go back to the code. Yes, it appears that the empty string is an invalid input for the detect function. There are a number of ways to handle this problem, but for simplicity, let's just return empty values when this happens. To save time, I've already made the changes here. Now let's go back to our shell and recompile so we can try again. And once again, rerun our tests. There we go. No errors. Great. Now let's deploy it to the database. As you can see, SingleStoreDB gives us a few different ways to do this. For this demonstration, we'll use a GCS bucket to host the module and have the database pull it from there. Again, to save some time, I've already done this part. Let's go to the query editor on the SingleStore portal to finish the deployment. This database already has the headlines dataset loaded into a table. We can see the schema for it here. All we need to do now is import our Wasm module from GCS. We'll do this using a variant of the existing create function statement. Since we used a Jwt spec to define the interface, we'll also pass that in as well. Looks like it imported successfully. The database was able to infer its own native types from the types we declared in the Jwt file. For now, SingleStoreDB only supports non-nullable types with Wasm UDFs, but we do plan to add support for nulls in the near future. Let's run a very simple query just to see what the UDF is actually returning to us. We'll use a sample of 10 rows. In the left column are random headlines from the dataset. And in the right column, we see the JSON representation of each corresponding prediction record returned from the wetlang library. In SingleStoreDB, converting a record to a JSON string is one way for us to easily see its contents. Now, before we wrap up, let's follow through on the question I posed at the beginning of the talk. We can use our UDF to construct a query that will find the most active news sources for, say, the English language. This may take a few moments. During this process, the database is executing our Wasm function many times in parallel, and it's happening from inside the engine's actual process. There we go. Interesting. It looks like the World News Network is by far the most prolific of the bunch. This makes sense, since they are largely a news aggregator and republish articles from thousands of other sources. Although this was a relatively simple research project, I hope I have been able to show you how Wasm UDFs can open up an entirely new dimension of analytic possibilities for your organization, and with only a small amount of effort. It will be exciting to see how this technology matures in the coming years as Wasm becomes more and more entrenched in our technical lives. I'm thrilled to have been able to play a part in bringing this feature to you, and I look forward to learning about the interesting and creative ways you may find to use it. On behalf of the Launchpad team here at SingleStore, thank you so much for tuning in. We'll see you next time.
Thanks for walking us through Wasm, Peter. As we continue with our focus on all things real-time, I'm excited to introduce Amy, Partner Engineering Manager at Dbt, and Julie, Senior Product Manager at SingleStore, to take you through how to power real-time applications. Julie, Amy, take it away.
Hello, everybody. I'm Julie Price. I'm a Senior Product Manager here at SingleStore, and I'm joined by Amy Chen, who is from Dbt Labs. And we're here today to talk to you about how SingleStoreDB and Dbt can really help to supercharge your real-time analytics and give you a great tool to have in your arsenal to use for building out your analytics transformations. So Amy, why don't you tell me a little bit about yourself and about Dbt Labs?
Thank you so much. Hi, everyone. I'm Amy Chen. I'm the Partner Engineering Manager here at Dbt Labs. In case you aren't aware what Dbt is, Dbt Labs is essentially the creators and maintainers of a tool called Dbt. Now, what Dbt is it's a transformation workflow that essentially allows anyone who's comfortable with SQL to create trusted data pipelines. How I like to think about us is we are a SQL-first product that our main goal is to essentially give folks the ability to test, document, version control, and create modular code for your data pipelines. And we do that with a SQL-first mentality. We have two key offerings, which is Dbt Core, which is that open source framework, as well as Dbt Cloud, which is the fully managed SaaS product that gives you an optimized Dbt workflow from development to deployment. Now, Julie, we have known each other for, I think, about a year, and what kicked this relationship off was essentially you decided to build a single store Dbt adapter. Could you tell us a little bit about why you decided that?
Yeah, absolutely. So I've actually been in the data and analytics space for a long time. I started hearing rumblings about Dbt probably back like right when the product was launched and when the company had a different name and everything. And so I started to notice this momentum and a lot of adoption and actually that you created a term called analytics engineers, which is really amazing. And so I started to see that, it was so widely adopted by analytics engineers and really commonly adopted in the data warehousing space. And single store is really good for data warehousing, but actually like the reason why people really adopt single store DB is because of the ability to do transactional and analytical processing together in the same database, not just on the same database, but on the same table even. And so that's really powerful. And so we see a lot of developers adopting single store DB. And so one of the things that really attracted me to Dbt for single store DB is kind of the developer centricity of the Dbt tool and the ability to do a lot of the things that developers want to do. And now you might think like, if I'm doing analytics on the same table that I'm doing transactions on, why do I even need Dbt? The reality is that most of the time, all of the data you need for analytics is not in the same table. Most of the time, the column names, the calculations, the expressions, like those types of things aren't really handled, and you still need to do those transformations. And so although we don't necessarily want to go through like a batch process to materialize transformations, Dbt is really powerful also for creating views. So you can create your models, which result in SQL views. And a lot of times those views are depending on other views, which are depending on other views and other views and other views. And that's really complicated. And so a lot of what Dbt brings to the table for that as well is the concept of observability or discoverability on like what the dependencies are of the various different views. So if I'm a developer and I go in and I change something, I actually know what I'm going to break. And I spent a long time in my career actually figuring out what I just broke. Sometimes it was weeks to figure that out. Back when I was doing data warehouse development. So that's one of the big reasons. And, as I mentioned, developers really want the same controls for their database objects as they have for other development assets. So they want to be able to build, test, document, and deploy, have version control, all of that kind of stuff. And so I think Dbt is just a really, really powerful tool to include in your development toolkit when you're working with single store DB. And that's why we built it. So is that kind of aligned with what you see within your community and usage of Dbt as well?
Definitely. So one of the things that we often get asked is like, why can't I just write this transformation in the UI? Or like, why can't I just do this on my own? But the benefits of Dbt isn't so much like helping you write that transformation. That's the easy part. That's the part you're actually being paid for. But it's really much about the overall framework. And we have been known to have very opinionated best practices because we have learned from years of just being in the industry about how to minimize your tech debt, how if you accidentally lose lineage, like what is a truly optimized workflow. And I think while you could definitely technically build this all yourself, with Dbt, you just get all those levers out of the box. And on top of that, we have the community that really keeps us pushing to create more. And if it's not there, they'll let us know. And also, if better yet, oftentimes they'll just create it and contribute it to the Dbt product.
Yeah, so speaking of the community is actually one of the things, it's one of my favorite things about DBT. And it's part of the reason why also that we looked at creating Dbt Adapter. We had people in the single store forum. So come in and say, hey, are you going to support Dbt? Will you have an adapter that supports all of the cool single store stuff that you have, like shard and sort keys and things like that, which we now do support in our Dbt adapter. That being said, like, why is the community so passionate about DBT? Like, I know that the community brings databases to you often. So why is that?
Yeah, I love in DBT Slack where someone's like, hey, do you support this? And then if not, we'll usually reverse it back and like, do you want to build an adapter? And when they say yes, it's like pretty epic. And I think the reason why we've set up this kind of conversation is essentially because, one, we are open source. So by its essence, the open source mentality often means that, like, if you use the tool, there's an expectation that if you love it, you will contribute back. And this sounds a little bit marketing centric, but like when we talk about the community, we at Dbt Labs think of ourselves as more like the maintainers, but we're part of the community, and it is not our community. We want to make sure we're facilitating those conversations, so it's easier to contribute, like lower the barrier entry to maybe you're an analyst and you have a good solution to an adapter and you believe this is the right way to do a workflow, then there should be no barrier for you to open a PR and start that conversation. So I think what's key here is like the DBT community, I joke a lot, is it's just extremely nice. And that's because a lot of times we've set into that space to leave your ego at the door and ask your question, even if it might feel silly. And this often creates that flywheel of enjoying being there rather than just coming to ask the question and then leaving. We see a lot of folks just bring in their friends and be like, you got to go check this out, because it's a place to have open dialogue.
So I mean, like I said, the community is one of my favorite things. Can you tell us, first of all, how we can find the community?
So if you type in community.getdbt.com, you'll get access to our community site, and then there's a link that you can fill out to get access to our Slack community. But I want to emphasize our Slack community is not the only part of the community. We have lots of folks just writing blog posts and stuff, but if you want ease of dialogue, there's 30,000 folks who are excited to chat with you.
Awesome. And one of my favorite places is the memes and off-topic chatter. So if you just need a good generation of memes, check out that Slack channel.
Now I have to ask, what's up next for Single Store and DBT? Are you about to make any memes about Single Store and DBT?
Oh, well, I mean, challenge accepted. So give us a few days on that. But so specifically for the Single Store Dbt adapter, there's a couple of interesting things that we have in the works. One, we support all of kind of your traditional database objects, tables and views, and support the Single Store DB specific constructs for those, like shard and sort keys and things like that. One of the really interesting requests that we've recently had from the community also is to be able to support pipelines. So Single Store pipelines is an integrated way to actually ingest data streaming or in batch into Single Store DB without any other like third-party tool. And so that's pretty amazing. So being able to manage the creation and adaptation of pipelines is one. And also folks on the other launch recordings would have heard that we've recently launched something called Workspaces, which is giving you the ability to like greatly scale out your compute resources against the same set of data. And so integrating things like having our Workspaces API that enables us to, spin up and spin down the workspaces through the Dbt adapter. So I think that that's pretty exciting stuff that we have going on. And I imagine that Dbt is not done making updates either. So what are you up to and what are you excited about?
Yeah, I think the spiciest thing that is starting to come up is that while Dbt is always going to be a SQL first product, we're starting to expand to support Python. So we're really excited for that, and you'll definitely hear more, especially if you join us at our conference, the Analytics Engineering Conference named Coalesce in October. Outside of that, as always, we're trying to expand all of the offerings that folks are interested in. So I definitely hope to see Single Store as one of the adapters in the near future on Dbt Cloud.
Awesome. So for those of you who are listening, if you want to learn a little bit more about DBT, about Single Store DB and our adapter in particular, you can go ahead and just type in Single Store DB and DBT into Google search. You'll get both the DBT documentation around the Single Store profile, how you get it set up and everything like that. And you can find more information also out on Single Store's site, including some blogs and other information as well. So Amy, I really appreciate it. It was awesome getting the chance to catch up with you today, to give the folks watching an introduction to kind of what DBT is and why we built the connector. So I just want to say thanks so much to you, and thanks so much to everybody who's watching.
Thank you so much, Amy and Julie. We're rounding out our track today with a bang as we take on breaking data barriers. Please welcome Jorge, co-founder and CEO of MindsDB, to talk about the company's inception as an open source in-database machine learning platform. Jorge, over to you.
We believe that data and leveraging data to make informed decisions is the best way to get a competitive advantage. And machine learning plays a crucial role in this process. MindsDB and Single Store together enable companies to accomplish exactly that. My name is Jorge Torres, and I'm very excited to present to you this partnership that we have with Single Store and MindsDB, and a little bit about MindsDB as a company. We started MindsDB as an open source project back at UC Berkeley in 2017. Then we went to Y Combinator in 2020. We raised a decent seed round to make sure that our open source project, which is a very mature open source project, got to the level of maturity that could be used by large organizations. And we're one of the most promising AI companies by Forbes, truly because this different idea that we have about making sure that companies can get to production as fast as possible when they actually have a machine learning problem in mind. And this of getting into production as fast as possible, it's possible because of the fact that if your data is in a database, you've already accomplished the most difficult part of any machine learning task, the data preparation task. Now, in a data-centric approach, the database is the heart and the beating heart of your infrastructure and of your decision-making process. Connected to your database, you have the analytics, the applications. You already figure out how to stream data and pipe data into Single Store, and you already know how to organize it. So since you've already cracked this very difficult part, the goal of MindsDB is to ensure that you can do the modeling and the deployment in a very similar environment to the one that you have for processing data in the database. So it allows you to do everything in SQL. Let me walk you through a demo that will show this end to end. The way that MindsDB works is that it is a database for machine learning models, yet everything that has to do with data, it delegates to the database, in this case, Single Store. We're going to connect to our Single Store database and do some sort of modeling and predictions. Now, in this particular demo, we're going to have house rentals data, and we're going to forecast this into the future. This is a really cool project because it's also a difficult one for machine learning, where you have a time series problem that has a high degree of cardinality, and it's also multivariate. Let's look at the data and explore and see how and why that is the case. So what we have here is data quarter by quarter, and it has some attributes. It has a moving average of the price, which is what we want to predict, but also it has the type, which it can be a house or it can be an apartment, and it has a number of bedrooms. So essentially what we're going to do here is, okay, for a house, roughly in the area of San Francisco, what will be, or in the area of Berkeley, what will be the price in the next following 3 or 4 quarters, taking into consideration all the information that I have of the moving average of all the prices that I can collect. Let's see how we can actually create a predictor for this. The beauty of MindsDB is that it abstracts all the life cycle for machine learning into one single statement. You have the data preparation, which is a query in this case. This query can be as complex as you want. For the sake of this example, it's a simple query, but if you need to do any form of data transformation, you can create this query here, put this query statement here, and that gets delegated to Single Store. On the other hand, if you want, you can create a view that creates all the transformations in Single Store, and then MindsDB queries that view. Now, The create predictor statement is similar to that of create a table, and it does a modeling part. And in the modeling part, what you're doing is, okay, I want to do a time series problem that orders by sales date. Essentially, that is the horizon, or that is the column that contains the information in which you're going to order information by. And then this one is a multivariate high partition or high cardinality problem because it has many different, number of bedrooms and number of types of property. And at the end, what you're telling is, I want to order by, group by these two attributes, and I want to be able to take into account the last 8 quarters in order to project the next 4. Let's run the statements. For the sake of this demo, I had already trained the model before, but I'm going to run this one. And so we don't have to wait until the model is done training. We can actually look at how the model performed in the last. Let's check out the model that I had trained. Now, what it's telling me is this model has a 52% accuracy across the 4 periods. So like it will get better, or the first result in the first quarter has a very good accuracy. And as the time progresses, the accuracy will drop. Still 55% is good, taking into account that you're trying to forecast something a year in advance. So let's look at how the model was built. This model was built using a neural network, LightGBM and SKTime. And then MyZB will try those and figure out which one will be the one that performs the best. In this case, SKTime is the winner, and that is how the model was being put together. Now, you may be asking, okay, but what data was put into the model? How do you encode this data? MyZB gives you this trick, which is the ensemble. You can dive into how that ensemble was built, and you can also experiment with it. You can change how and which parameters you want. Even if you wanted to use only SKTime, or if you wanted to use a transformer, you can specify this capability on the create predictor. But let's look at how the ensemble was put together. So MyZB realized that the moving average is one of the time series columns. So it's going to encode it as numeric values and code it into another array. The same thing for sales, date, then the type. It realized that, well, you only have 2 categories here, so let's put in a binary encoder. The number of bedrooms, let's do a 1-hot encoder. And then at the end, it decided that it was going to try a neural network, LightGBM array, and SKTime. Well, now, having said that, now you can query the model as if it was a table. Since this is a time series model, you can join it with the data that you have. Let's actually make a query to predict what would be the prices for the houses when the bedrooms are 2 in the next following quarters, and for the date greater than the latest. This is a unique statement to the way that MyZB does things, which is, well, you actually want to forecast something into the future, assuming that the latest data point is a data point of today, then the latest 4 would be the next 4 quarters. And that is crucial to forecasting. And we make this simplification. So when you run the query, you don't have to go and fetch the last 4 or the last 8 of properties that are houses and number of bedrooms too. MyZB does this kind of like organization for you. Let's make this prediction. Okay, and there you have it. Forecasting for the following 4 quarters given the latest information. Thank you so much for being part of this demo, and looking forward to see what all of you can do with MyZB and SingleStore. And before we're done, some resources for you. You can get started with SingleStore. There's a 500 in free credits today. Follow these links. Also, there's a very comprehensive guide for anyone that has any questions about SingleStore. Go to the SingleStore download and start using the product. And for MyZB, you get the cloud account for free as well. We, of course, are an open source project. You can deploy it on your premise, but you can go to cloud.myzb.com and you can get started within a few clicks. Join our community, GitHub, Slack. Looking forward to see you there. Thank you.
Thank you again to our engineers for giving us a closer look at the latest features in SingleStore DB, as well as our incredible speakers for sharing their take on powering real-time applications. I hope you've enjoyed this breakout track for Revolution 2022. If you missed any sessions or would like to watch them again, You can find them on our SingleStore YouTube channel. If you can't wait to try these new features in SingleStore DB, click the link to get started with your free trial, including $500 in free credits for our managed service. Thank you again for joining us for Revolution 2022.